Okay, so today we're going to talk about solving logarithmic equations. You did this in Algebra 2, so it's more like a refresher here. So when we're solving logarithmic equations, there's two ways. You'll have two different situations. If you're presented with something where you have some log of some base, let's just say some base A of some B is equal to C. So, all we have to do here is use the definition. So you're going to take it and you're going to switch it into exponential form, and we're going to solve from there. So then, also, if you have some log of some base of, I don't know, let's just say x, and then we have it equal to another log of the same base, and we'll just say y, then we can set their insides equal to each other. So what we can do is we can say that this is equal to that. X is equal to y. Then x is equal to y. Alright. But as we're doing these, we gotta make a little special note. And this is true for all of these. You must check your answer. You must check your answer. Because we have something called an extraneous solution. So, if you check your answer, the way you know something is an extraneous solution, so you try to take a log of some kind of negative number. That can't happen. If you put it in your calculator will go bananas. So if you have log of a negative number, what we have is, I'm going to define it for you, an extraneous solution. And an extraneous solution is just a solution that does not work. Okay, so let's take a look at these examples. The first one, we have some log equal to a number. So that's our first situation there. So what we're going to use is we're going to use the definition of a logarithm. So let's use our cab and our backwards alphabet. So we have C, B, and then A. Remember, we're going to do C to the A power is equal to B. So let's rewrite that. So we're going to have 4 to the 5/2 power is equal to x. And then at that point, go in your calculator and put 4 to the power of 5/2. Make sure you put 5/2 in parentheses here, and you're going to end up with 32. Now, we need to make sure this isn't extraneous. So whenever we go and plug 32 in for our x, 32 is positive. We're not taking a log of a negative number, so 32 checks. And I'm going to write checks because we checked it. All right, so let's look at B. Same thing here. We got the same situation. We have log of something is equal to a number, so we're going to use the definition. So this is C, B, A, and remember we're going to switch it to C to the A power is equal to B. So we're going to have 5 to the 3rd power is equal to, and B is that entire expression, so we have x minus 2. Okay? So you can go on your calculator, put 5 to the 3rd power. 5 to the 3rd power is 125. And then we still have x minus 2. And to get our x isolated, we simply add 2 to both sides. And we get 127 is equal to x. So, lastly, let's check it. If we were to plug in 127 right here, we'd have 127 minus 2, which is 125. And we can take the log of 125 because it is positive. So we're going to say, boom, here's our answer, and it checks. Okay, so let's move on. For example C, this is like case 2. We have some log of the same base is equal to another log of the same base. And these are singular bases. Singular logs. So literally all we have to do is take the insides, and all we have to do is set them equal to each other. So we're going to have x plus 2 is equal to 6. Then to solve for x, subtract 2 from both sides, and we get x is 4. And the last thing we have to do is go back and check it. So we're going to look and try to plug it into our original. So if we plugged it in right there, we'd have 4 plus 2, so we have 6. And we can take the log of 6 because it's positive. So this is our answer, and it checks. Similarly, let's look at D. We have a log base 7 is equal to another log base 7. We got singular logs equaling to each other with the same base. So, like I said, we're going to take the inside and set it equal to the inside. So let's see here. We have x squared minus 2 is equal to x. Now what we have here, so we have a quadratic. So we've got to pull back some of our algebra skills, and we're going to have to solve this quadratic. We're going to have to factor it. So what we need to do before we factor is we need to get everything to one side and set it equal to 0. So I'm going to subtract x from both sides. And what we have on the left-hand side is x squared minus x minus 2 is equal to 0, since we took everything away from the right-hand side. Now, I hope you guys remember how to factor. So let's factor this guy. We're going to have x and x. So we've got to think of two numbers that we're going to plug in here that are going to multiply to get negative 2, but they're also going to add to get negative 1. So first of all, to multiply to get negative 2, you're either going to have negative 1 and positive 2, or positive 1 and negative 2. And since we're adding to a negative 1, we got to add to what that number is. We need to use negative 2 and positive 1. So those are our terms. And we set that equal to 0. Now, if you remember from algebra at this point, we have to take both of these terms, this one, and set them both individually equal to 0. So we have x minus 2 is equal to 0, and then x plus 1 is equal to 0. So when we solve this, this is when we're going to end up having two solutions. So we might end up with an extraneous solution at this point. So let's solve the left-hand side one. We're going to add 2 to both sides. And we get x is 2. Okay. The next one, got to subtract 1 from both sides. And we get x is negative 1. So, but I want to point out to you, just because you have a negative solution doesn't mean that it won't check, because sometimes they'll check. So let's look at x is equal to 2 first. So we're going to go back to our original. So on the right-hand side, we'll be good, because we'll be taking the log of a positive 2, which is completely legal. On the left-hand side, we'll have 2 squared, which is 4, minus 2, which gives us 2. So we're good to go there. We're taking logs of positive numbers. So this one checks. And let's take a look at negative 1. Well, right off the bat, before we even plug it into the left-hand side, if you plug it into the right-hand side, you'll have log base 7 of negative 1. And are we allowed to take logs of negative numbers? Absolutely not. So guess what? This is actually not a solution. And we're going to write extraneous beside it. So we only have one solution for this problem. Okay, let's take a look at this one. So this is different than what we've been dealing with. We've been dealing with a log is equal to a log, or a singular log would be equal to a number. Now, we've got to pull back and use some of those properties that we have. Remember the power property, the quotient property, and the product property. So what we have here, let's look at the left-hand side. We want to try to condense this to 1 log so that we can set whatever the 1 log is equal to 16. So if you look at this 2 in front, we have the power property. So we're going to rewrite log base 5 x, and that 2 is going to come up and make that squared. And then we have log base 5 of 4 is equal to log base 5 of 16. We haven't touched the other 2 terms. Now, if you take a look between those 2 logarithms, we have a minus sign, which means that we're going to use our quotient property. So for our quotient property, we do the first one over the second one. So we have log base 5 of x squared on top over 4 is equal to log base 5 of 16. Now it fits that first scenario that we were talking about earlier. We have a log is equal to a log. So we can set this equal to this. And it's straightforward algebra at this point. So if x squared over 4 is equal to 16. Now to solve for x, we need to multiply both sides by 4. And we get x squared is equal to 64. And then the next thing we got to do is we got to get rid of that squared. In order to get rid of a squared, we got to take a square root of both sides. Now, you got to remember that whenever you take a square root, what you get out is plus or minus whatever the square root of 64 is. The square root of 64 is 8. Now, don't forget, whenever you take a square root, you're going to get out 2 numbers. You're going to get positive 8 and negative 8. So x is either equal to positive 8 or negative 8. And who knows, it might be equal to both. But we've got to check for extraneous solutions to notice that. So at this point, let's go and let's try to plug in. Let's do positive 8 first. The only place that there's an x in our original is right here. And that's completely legal. We can take the logarithm of a positive 8. So this one checks. Positive 8 checks. But in case you haven't noticed, if you plug in a negative 8 here, we're taking log of a negative number. And we cannot do that. So this right here is extraneous. So we actually only have one solution to this problem, which is just positive 8. Okay, moving on, we have another example. We got logs all over the place. So we're going to try to condense both the left-hand side and the right-hand side. Okie doke. So let's tackle the left-hand side, and then we'll get to the right-hand side. Now, if you look at the left-hand side, we've got this 2 out in front, which means we have our power property. So let's rewrite this. Log base 3 of 0.1 plus log base 3 of x squared. Okay? And I'm going to rewrite the right-hand side. We haven't touched it. Okay, now let's keep looking at the left-hand side. We have a plus sign between our 2 terms, which means that we're going to have the product property. So we're going to multiply 0.1 times x squared in one single logarithm. So you have log base 3 of, and I'm going to put some parentheses around this guy, 0.1 x squared. And we still haven't touched this side. Okay, we're in business. The left-hand side is condensed to a singular logarithm. So now let's look at the right-hand side. So over here we don't have any power property, but we do have product property because we have addition. So I'm going to rewrite the left-hand side because we just finished it. And we're going to rewrite the right-hand side, but this time we're going to multiply 2 and 5. So we have log base 3 of, and 2 times 5 is 10. Now, what we have here is a case like we were talking about earlier. We've got a log with the same base is equal to a log with the same base. So we're going to set their insides equal to each other. So we have 0.1 x squared is equal to 10. All right. Now, we are going to divide both sides by 0.1. So x squared would be equal to, and you put that in your calculator, you get 100. So now, we're going to take the square root of both sides to get rid of the squared. But remember, whenever you take the square root, you're going to get out what? Plus or minus whatever that square root is. So you get plus or minus 10. Now, I promise you, sometimes these negative numbers will work. So we have x is equal to positive 10, or x is equal to negative 10. So we've got two solutions here. Last thing we got to do, check it. Let's look at positive 10. So if we go back to the original, if we plug in a positive 10 here, we're good to go. We're taking a log of a positive number. So that one works. So let's box it. We're going to say checks. Then negative 10. Womp womp. Right here, if we take the log of a negative number, it's not going to work. We have an extraneous solution, so that one does not work. I'm going to write beside it extraneous. Well, just remember that whenever we're solving log equations, sometimes we have to use our skills of condensing expressions to get what we want. We got to have those two cases. Either we have a log is equal to a number, or a log with the same base is equal to another log with the same base.